We're going to talk about pricing and support that align with our environments. How do you buy Azure? How do you get support if you get into a problem? That's our course and what it's designed to help us learn more. And so, cool thing about this, some of you are going to take the exam. And when you look at the exam, guess what? We have 4 study areas for the exam that align to those same 4 modules. Now, you'll notice on the right-hand column, they have the weights. What's that mean? Well, our exams kind of come out of a random pool of about a few hundred questions. You're going to get anywhere between 40 to 50 of those questions based on those different weighted areas for you to study and work with. When you look at the right-hand column, that's more than 100%, but that's okay because everybody's exam is going to be different. You're going to get different questions. The nice thing about this is that when you look at this exam, you pass it once and you're done. And you don't have to worry about taking it again because it's the fundamental level. Now, the other exams you may take on your certification journey, you might have to take the exam after a couple of years because Azure changes so much. Now, if you're looking to study, if you're looking to learn more about Azure fundamentals, look at http://aka.ms/azfunpath. This is an online version of this same course we're going through. They have some hands-on exercises. It gives you some additional materials to read and study and prepare for the exam. In fact, when I took the exam, that's the same area that I went on to learn more about the areas that I was a little weak on. So every exam has a challenge, and every exam you want to be prepared for as you go into it.
Hey Matt, what is actually a passing score for the exam?
So the passing score, great question, we get this all the time, it's 700. So if you get a 700 or higher, you've passed. Now, folks, let me be honest with you. You're going to have friends, and some of you may those friends, and you might be that friend that say, well, I got an 800 and you only got a 700. Don't let anybody do that to you. When they say that to you, and so if Garrett were to tell me, says, Matt, I got an 800, you only got a 750, I'd be like, well, Garrett, I'm glad you got the easy exam because I got the harder to the exam. So the score is there. Now, with that said, if somebody comes up to you and say they got 1,000, that is worth a crisp high five, maybe a hug. That means they got a perfect exam. They didn't miss a single question. And I don't care what exam that you take, 1,000 is 1,000. That's impressive no matter what anybody will tell you. So understand, passing 700, if you get a 700, you pass. And it's no different than somebody gets a 900. They pass too. It's just like a hit in baseball. A hit is a hit is a hit. A pass is a pass is a pass. So when you look at this exam, folks, you really just want to get over that hump to pass it. The exams are tough. You have to study and work with it, and that's why we have this course for you. That's why we have the online version of this course for you, because we want you to be successful with that. Our promises over this course is really we're going to have some fun. Heck, it's in the title. I think it's even Garrett's title, as a matter of fact. We're going to have fun. It's Azure Fundamentals. Learn at least one thing. Certifications are important, yes, especially if you want industry-wide recognition. But really my goal is to get you skilled up in Azure. I want you to use Azure in your company. I want it to use possibly in your life. We have free services, and we'll talk about that in Module 4, that you can leverage that if you're part of the community and maybe you just need a little bit of compute power to support a nonprofit or an organization. Guess what? Azure may have something free for you to solve that problem. And lastly, we're going to make ourselves available to you throughout this course. We're going to have some questions and answers as we go through. You're going to let us know, engage, and enjoy. This course is for you. Now, who am I? My name is Matt Hester. I've been with Microsoft for 19 years. There's my email address if you need to ask me questions about the course of what we're going to go through and study. But I live in Frisco, Texas, and if you don't know where that is, it's a northern suburb of Dallas. I live 3 miles away from the Dallas Cowboys practice facility, the NFL football team in America. But the cool thing about this, I am not a Cowboys fan. I am a Cleveland Browns fan and an Ohio State Buckeye fan. So if you are a Buckeye fan, OH,
I.O.
There you go. So Garrett, you at least know the proper response inside of it. But I also have lots of certifications. I've been taking certifications pretty much my entire career before and after Microsoft. The cool thing about this, I'm in my dream job, but the reasons I get up in the morning are my family. My reasons why I do this job and I love this job so much is I get to support my family. I have a wonderful daughter, Nicole. She's a flute player at Stephen F. Austin in Nacogdoches, Texas. The cool thing about Nicole, she's a math major. She wants to be a math teacher. My son Mitchell, he currently stands at 6'7", and he's a volleyball player and a trombone player. It's kind of a natural instrument, a really long instrument with a really tall person, and works perfectly. And then Caitlin, my heart and soul, and everybody will tell you that Caitlin is got me wrapped around a little finger. That is a true statement. She's a French horn player, and I love her to death, but she loves bacon. Trust me, this is important for something we'll talk about later. And then I have 2 fur babies, Pepper and Sugar. We're doing the annual spring thing in Texas where we're taking pictures in the state flower of Texas, which is the Texas bluebonnets. And so you have an idea of what we do in Texas every spring. You can see all the forced fun smiles that we have. But the cool thing about it, I have Garrett with me throughout this course. So Garrett, why don't you talk a little about who you are?
Sure, yeah, thanks, Matt. So I'm Garrett Bundy, as Matt mentioned, and I am a director on our fundamentals team. I look after a team of trainers that are based anywhere from in the United States all the way through the rest of the world, in China, Japan, all over the place. I'm based in Los Angeles, California. I also have been taking a lot of certification exams throughout my career. Been at Microsoft for 14 years, so not quite 19 years like Matt, but I've been here for 14 years. Most of the same certifications that Matt has, and I enjoy the technical part of this. And as far as my reasons why, very similar to Matt, it's my family. So my wife, my older children, my oldest son, James, who's in college in his second year, Skyla, who started college this year. She goes to UC Santa Cruz, so go Banana Slugs. And then my other daughter, Kaylee, who's in high school, my son, Caden, who is in first grade, and my daughter, Devin, who's a kindergartner. And really, my family is why I get up in the morning and why I do everything I do. So very similar to Matt, but that's why I do what I do.
Awesome, and I love your title, Fundamentals. It's perfect. It fits what we're going to cover today. And let's go ahead and get started with Azure, Module 1, Azure Fundamentals Cloud Concepts. And in this module, we're going to talk the basics of cloud computing, from private computing to public computing to hybrid cloud computing that we have. The cool thing about this, whether it was Azure, Amazon, or Google, these terms are industry standard. We're also going to focus on kind of the key terms of infrastructure as a service, IaaS, platform as a service, or PaaS, or software as a service, SaaS. These are, once again, terms that we use broadly across the industry. So the great thing I love about this module, it sets the stage. Now, if you're listening to this and watching this and going, wait a second, I got all that stuff. The one thing I want to stress to you, especially when you take the exam, is you have to think like a Microsoft person. So yes, we use industry standard terminology that's for all of these services, but when you take the exams, you kind of have to, if you work for a company that's been using Azure for several years, you might have to ratchet yourself back just a little bit to understand what we're asking, because we have to ask a question at a general level, not specific to your company. I love the fact that if you're using Azure, thank you so much. But the exam is going to test that general Azure knowledge, that general cloud foundational knowledge as we go into it. So let's talk about some of the key terminology of why we use cloud services, as well as some of the foundational things. So why do we use cloud? It's all about the compute power. When you think about Amazon and Google and Microsoft, how big our data centers are, well, how can you leverage that power? Well, the most common way is using compute. And compute doesn't always mean virtual machines. Understand, everything you do in a cloud service is run by some piece of hardware and computer underneath the covers. The cool thing about this, we have a huge amount of resources for you to leverage, so we can do things that you may not have been able to do, like analytics, being able to just do truckloads of data, petabytes and terabytes of data, and we want to find out that seasonality. We now are on a network, and a fun fact about Azure, last time I checked, we have enough fiber to go to the Earth and the Moon 3 times. You're on a private network, and Microsoft has gotten really good at this. A lot of people think we're new to the cloud business. We've been in the cloud business since 1995. Our first cloud service was Windows Update. So we've been doing this for a long time. We've gotten really good with our networking. We also now have storage. Now, when you think about storage in our environment, we'll talk more about this in Module 2. The cool thing about storage is that we have really just a wide, vast array of storage for you to leverage for files, databases, anything else that you want to store inside the environment. So why do we use cloud computing? It provides us ability to leverage resources that we otherwise couldn't do on-prem, and hopefully at a point that's less expensive than what we do on-prem. And we're going to talk more about that in this module and in Module 4, because it's not necessarily just about how much a machine costs, but the whole total cost of ownership. So when we talk about why we use cloud computing, to do things that we couldn't do normally, but also do them at a price that's less than what we could do on-prem. And so when we start working with Azure and we start working with our cloud terminology, we have some very key concepts and availability that we have to understand, that how we think about Azure. And the first one is high availability. What is high availability? Really, it's the ability to make sure that our services are up and running as much as we can. Now, when we think about high availability, it's making sure that at service, when somebody comes to my website, it's there for me. When somebody comes to my database, it's there for me. It's available. Now, when I think about availability, Garrett, what do you think? Do you think that's a Microsoft responsibility? Is that our customer's responsibility? Or do you think it's both of our responsibilities?
I think it's probably a shared responsibility.
Definitely. And you used a great term there. You used shared responsibility. And when we look at availability, We're going to provide a platform that has guaranteed service level agreements, and we'll talk more about those in Module 4, but we also have to give you an ability to design solutions so they are available, and we'll talk about in Module 2 two very important concepts, and they're critical. By the way, exam tip, you'll see these two concepts, availability zones and availability sets. You'll see them on every exam you take from AZ 900, AZ 103, the architect exams, AZ 300, 301, and we'll change those names as we grow them, but trust me, you're going to see them in the wide variety of those things. We also have two terms, scalability and elasticity. Now, scalability, we've been doing on-prem for years. You've been able to scale up. What's that mean? When you scale up a resource, you add more memory, you add more CPU, maybe a bigger hard drive. You're trying to solve a problem on a server. Think, for example, or imagine a query that's running in our database where we just need that query to run a little faster. Well, we can't solve it with another server, but we can solve it with more horsepower, another CPU maybe. That's called scaling up inside the world. Now, if you were to take the hardware away, which we very rarely did on-prem, that's called scaling down. Whereas, what if your website is announced on a popular TV show and all of a sudden you need 10 more web servers to handle that problem? It's called scaling out. And we have scalability that we can use. And by the way, if you remove those servers, it's called scaling in. Generally speaking, we've been scalable in our cloud technologies for forever, but also we've been doing this on-prem. But now we have this term elasticity. What's elasticity, Garrett? What do you think? Or inside of it, so we're elastic. We have agility, means we can do things very fast. For anybody who's ever done anything in the cloud, we're talking minutes. In Module 2, we'll create a virtual machine in minutes, from something that doesn't exist to something fully running in just minutes. Think about how long it takes to work with those environments. Take along how long it takes to put them on-prem. Well, guess what? Makes it very agile in the cloud when we can just start working right away. Then we have fault tolerance. Fault tolerance is an interesting concept. Is what happens when hardware fails. Everybody has maybe woken up in the morning and you hear that tap, 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 tap of the old magnetic drives when a drive head broke inside of it. You have fault tolerance. Well, whose hardware are you running on here? You're running on your cloud provider's hardware. You're running on Microsoft's hardware. And so when we talk about fault tolerance, so Garrett, I'll ask you the same question again. Is this a Microsoft responsibility, a customer responsibility, or is it both of our responsibility?
I think fault tolerance falls more on us as Microsoft.
Most definitely falls on us from a standpoint when we talk about the physical hardware and the framework. It is definitely our responsibility to make sure that we provide hardware. Because at the end of the day, let me on a secret, guess what? Azure, giant data centers. In Module 2, we'll talk about how big these data centers are, but it's physical hardware. So we have to provide fault tolerance for you. Now, when we start thinking about bigger concepts about business continuity and how do I make sure my web server that's running on-prem, if it has a fault, how can I fail over? Whole different concept of where cloud can help you provide that. But in the context of right now in our fundamentals, fault tolerance is how we handle those errors on our side. We want to have fault-tolerant solutions. You don't have to worry about that. And this is one of those, once again, Garrett used that term, shared responsibility. You're on our hardware, which means we have to be responsible for you as you're our customers. We have to make sure it's up and running. Some other key terms. We have disaster recovery. This is another one of those ones when we think about, well, we can use Azure as a disaster recovery platform. And you think about just something as simple as backup. Azure's a great backup target. You have your on-prem resources, you back them up to cloud technologies. Now, if that on-prem resource goes away, it's up in the cloud. And everybody thinks, hey, that's great, it's a great backup target. The cool thing about Azure from a disaster recovery standpoint, it's also a recovery environment. If I don't have that server on-prem to restore the data to, you can create a virtual machine. We'll learn more about those in Module 2. But also disaster recovery takes on a whole nother level when you start using shared responsibility in the cloud provider. What happens if our data centers go down? How do we work with Azure to make sure that, hey, it doesn't impact your application? And we're going to talk about our concept of geographies and region pairs, all in Module 2 to talk about how we do disaster recovery. Then we have global reach and customer latency capabilities. These two are tied at the hip. When you think about an environment where we have 56 regions around the world, where are you going to put your stuff? Where are you going to put your regions? Generally speaking, you're going to put it in the regions that are close to you. Wherever you happen to be in the globe, wherever that solution is going to be used, you're going to put that information close to it in a way that we don't have to travel across the globe. Now, here's the cool thing about Azure. If you did have to travel across from one region to another, you're on our network, a really high-speed network. And one of our case studies is NBC Sports, and you can look this up online. They actually use the Olympics, uses Azure to help distribute the media files. So if you're watching the Olympics anywhere online, chances are you're coming out of an Azure data center. And NBC Sports is using that global reach and customer latency to make sure that people can watch whatever Olympic event they want to watch. Either stream it live or watch a recorded event. The other one sometimes causes people a lot of trouble with the one, predictive cost considerations. And I hear this all the time. I will not use the cloud because I don't know how much it's going to cost. True, we're going to give you an estimate, but it's a very predictive estimate of how much it's going to cost you. It's a consumption-based service. So like here, when I'm at home in Texas during the summer, we turn on the air conditioning. Well, how much is my electric bill going to be? Well, I know in the summer it's going to be higher. And based on the seasonality, I have a general idea of how much that's going to be. It's still predictive. I can still budget for it. Is it the exact number? No, it never will be. And in Module 4, we'll talk about how to leverage the calculator so you can be predictive about this. And the last one, oh boy, Garrett, this one always causes problems, security. So when you think about security, what are some of the things that you think about when you think about cloud and security?
Well, wanting to protect my environment from malicious actors out there. I'm putting my data in the cloud now, so I need to be more conscientious about how I'm putting that data, where I'm putting it, and who I'm trusting with my data.
Yeah, and I think about it, whenever I hear people about security, the one thing they worry, they lose control. Right? They're no longer they don't see the hardware anymore. They don't see the blinky lights. They don't see the servers. They don't have, and I always joke with customers when we do these classes live in front of folks, we have, hey, look, do you have a friendly receptionist or an unfriendly receptionist? Now, folks, you want to err on a courteous but unfriendly receptionist. Why? Because if I were to go to any of your companies and say, hey, my name is Matt, I work for Microsoft, can you show me where the lunchroom is? Well, they walk me back and maybe buy me a cup of coffee along the way. Yeah, good, I love it, by the way. But that could be a person here, how they know who I'm at. So we have to look at security. Once again, this is another one of those shared responsibilities. I often say when you move things from on-prem to the cloud, it's going to be as secure as it was on-prem when you move it to the cloud. However, the cloud has some built-in capabilities. We'll talk about these in Module 3, and one of them, let's say you have a website. One attack that your hackers may come after you is called a distributed denial of service, or a DDoS attack. And what that is really an attacker of your organization not really trying to compromise, but what they're trying to flood is your website with so much traffic, legitimate traffic can't come in. Well, when you put things inside of Azure, automatically you have DDoS protection. It's turned on for every customer and it's free, the basic SKU. There's another SKU that we'll talk about in Module 3 that costs a little bit of money. But when I think about security, it's a really big term. In Module 3, we're going to talk about some of those key security concepts, and really security in the cloud is understanding how we talk to the cloud and make it more secure. How can we do things that we didn't do on-prem, but now we have a chance to fix when we move things in the cloud? So when we think about security, it's really that shared responsibility. You have to think about it from your side, and we have to provide you an environment from our side that governs that. And we'll talk all about that in Module 3. At least give you kind of the tip of the iceberg. When we think about some other key terms, we have economies of scale. What does that mean? means basically we have so much hardware, we can offer this to you at a cost that's less than what you have, and we pass those benefits on. The more efficient we get in our cloud, guess what? The less expensive those resources are going to be for you. In Module 4, I'm going to show you this. We have costs for virtual machines, and if I run them in West, it has a certain price point. If I run it in West 2, which is one of our newer data centers, the price drops. That's the cool thing about cloud when you think about what's happening in the cloud technology. And this is different than what we've ever done before in technology. Think about when you bought a version of software. Version 1 had a price point. Version 2 was a little more expensive. Version 3 was more expensive. Version 4 is expensive. But what's happening in the cloud? You have some very strong companies in the cloud, and guess what? Competition is driving a price point that is going down. Now, of course, Garrett and I are biased because we are Microsoft, so we're all about Azure. We'll talk about that journey in just a moment, but we get economies of scale because we have these large data centers, and we can pass those costs along to you. We also have another benefit of cloud, and this is capital expenditure versus operational expenditure, CapEx or OpEx. Capital expenditure is what we've done for years on-prem. You had a large upfront cost. You had to build a data center. Now, think about this. You might think, oh yeah, I had to go buy the racks of computers, I had to buy the cabling, I had to do all that. You had to have a building. You had to have some place to actually put all that stuff in, then run power to it, then run your internet access to it. What I'm starting to get to think of is all the upfront costs that go into this and all the total cost of ownership. We had high upfront costs and they devalued over time. One of the accounting principles, when you acquire an asset, the minute you acquire it, it starts to go on the books and devalues. This is different because that capital expenditure is all about on-prem. Cloud is operational expenditure. You get a monthly bill. There's no upfront costs. Now, you might have costs to train and use your people, but there's no upfront cost to use the technology. It's pay as you go. As you work with this, you basically deduct the expense from your tax bill in the same year. You get billed immediately. And when I say immediately, you start using Azure on, let's say at the beginning of a month, you're going to get the bill at the beginning of next month for the previous month. So you do get billed immediately, but the bill shows up the next day or the next month or the next period of time. The cool thing about this is that's how all cloud services are, operational expenditure. And when we look at the different models, especially when you compare IaaS and PaaS versus SaaS, how that operational expenditure model changes, and we'll talk about that in just a few minutes. When we think about consumption-based model, this operational expenditure, no upfront costs, you don't have to purchase or manage any infrastructure. And this is when we looked at IT pros, and I know, Garrett, you talked to IT pros as well. When cloud first started, the sky was falling, right? Because they thought they were going to lose their jobs, right? Did you have those conversations as well?
Yeah, I had those conversations on a very regular basis. Everybody thought, I don't want to get into the cloud. This is not where we're going, because they felt like they had to protect their domain on premises.
Yeah, and what they didn't understand is, unless they like to rack and stack hardware and run cable, which if you've ever talked to anybody who's ever done a data center in the history of ever, nobody likes to rack and stack hardware. Nobody likes to run cable. And something, by the way, just kind of picking up people that are born in the cloud, there's a lot of companies that don't have the joy of doing that stuff. I think, by the way, Matt's personal opinion here, before any company can use the cloud, they have to go make an RJ45 cable and crimp it properly before they have to do this, something that, the pain of this. But when we talk to IT pros about this, guess what? Oh wait, I don't have to make an RJ45 cable? No, you don't. You don't have to worry about the hardware. That's our responsibility. But what about the server up there? Do I have to back it up? Yep. Do I have to maintain it? Yep. Do I have to configure it? Yep. And the list goes on. You still have to architect these things. Even though we have the physical infrastructure done for you, you still have to architect virtual networks. You still have to architect the storage. You still have to worry about making sure the security is there. So when you think about this consumption-based model, it takes away a lot of things we used to do, but there's still plenty of work inside the world that we have today. The more you use, the more you pay for. And when you're done using it, and think about scale out for a moment. We just got mentioned on our website just got mentioned on a popular podcast or TV show, and all of a sudden we need 500 more servers to govern the traffic. Well, I just spin them up. 500 servers. Solves my problem. The minute I don't need it anymore, I simply start taking them away and I no longer have to pay for them. It's a huge benefit. That elasticity is huge around consumption-based model. It's hard to put in a price point, but think about how you would have done that on-prem. You would have spun up all those servers. Now you're kind of stuck with all those servers. So when you have a consumption-based model, we help you lower the cost for those same solutions, and in some cases, do things you couldn't do before. Let's talk about the types of cloud models we have. And we have three, and most of you have heard these terms. We have public cloud, private cloud, and hybrid cloud. Let's start with public cloud. What is it? You're going to Microsoft, you're going to Amazon, you're going to Google, you're going to somebody that provides the cloud services. You don't own them. You basically use those resources. You leverage those resources for whatever you want to do. All the cloud resources that you go into are going to be accessed over some kind of secure connection. And we'll talk about these in Module 2 as specific to Azure. In Azure, we have a couple of ways that you can come in and work with it. We have ways you go over the public internet. You can even get, via a technology called ExpressRoute, a private dedicated link into Azure. And we'll talk about that in Module 2, but you're going somewhere. You're in that shared responsibility model. Almost every organization that's born in the cloud, that's all they know. All they know is public cloud. But a lot of your organizations that, as we go through and look at our customers today, you started off with private cloud. What's private cloud? Think on-prem. It's your data center, which means you had full control, full security. It was yours. You also had the full responsibility for managing that private cloud. In other words, you had to worry about everything. You had to worry about the rack and stack, the cabling, the physical infrastructure. If something failed, you had to replace it. If somebody supported it, you had to solve the problem. You had to have all those resources, and that's okay. Guess what? Everybody started with private cloud. Most of our organizations started with private cloud. Now, when you think about this, how do I connect the two? It's called hybrid cloud. And all hybrid cloud is connecting the public cloud with your private cloud to allow applications to run in whatever is the best location, whatever the most appropriate. We still have customers that are in this model. Why? Compliancy. They might have to run a certain part of that application on-prem for something internal or governmental compliancy, or maybe a compliancy we don't meet in the cloud, and that's okay. But what can we move into the cloud? Let me let you in all a secret. For those of you who think, hey, we've never used Azure, we're looking to jump into that. If you're currently using Office 365 today, you log on with an ID via Azure Active Directory. And most likely, the IT department of your organization took your on-prem Active Directory environment and connected it to Azure Active Directory. In other words, if you're in Office 365, my friends, guess what? You might already be in hybrid cloud for your identity. The key thing there is, one, you're already there. Two, I mentioned a very specific workload. And so when people think about hybrid cloud, they think, oh, I have to do everything. No, no. Pick the workloads that make the most sense and run them in the appropriate location. Well, I have to run this on-prem, but I can do this other part up in the cloud. Find what works out for you and get hybrid cloud. Hybrid cloud gives you the most flexible model that we have, the most flexible design, because now it's kind of do what you want to do. Microsoft came out with a marketing term several years ago, and I loved it. Cloud on your own terms. Now, make no doubt about it, we are a cloud-first company. We believe in Azure. We believe in Office 365. We believe in all our cloud services that are out there. But we want our customers to choose what's important to them. So cloud on your terms at a Microsoft, even at a Microsoft employee level, means a lot. Because one of the few cloud providers allows you to pick and choose. And if something doesn't run right in the cloud, you can bring it back down to on-prem to work with it inside of there. When we look at those different cloud module comparisons, just a quick refresh. Public cloud, it's no capital expenditure, it's operational expenditure. We have applications, we have the agility of the cloud. Organizations pay only what you use, consumption-based. Private cloud, you have full control over your security, over your resources, everything, but you also have full responsibility over that. Hybrid cloud gives you the best of both worlds. You get flexibility, you determine what makes the most sense to run your applications, and that's hybrid cloud. Now let's talk about the types of cloud services that run in those different models. And really now we're going to focus in on the key terms: IaaS, PaaS, and SaaS. And really it's a level of responsibility. So when you look at infrastructure as a service, if you look at where it's governing on this slide, the physical data center, that's us. The physical networking, firewall, and security, that's us. The physical servers and storage that run your environment, that's us. Now what are you responsible for? Operating systems, the applications that run on top of them, or the configuration and development of those applications. That's infrastructure as a service. Now, if you look at platform as a service, guess what you don't have to worry about? You don't have to worry about the operating system. There's definitely a compute resource behind those PaaS services, but you don't have to worry about it. Then you have SaaS services, where generally speaking, you just have to configure that client to work with it. So if you use any streaming media today, if you subscribe to any of those, watch movies on planes or download that stuff, guess what? Most likely using software as a service. The great thing about software as a service, it's a very predictive cost model. Generally speaking, it's a $10 per user per month kind of thing, depending on what service you're using inside of there. Now, I like this slide because it kind of lays out the story, but really most of you have probably seen a slide like this of how we describe the shared responsibility model. So Garrett brought that up. It's a huge term, right? If you're on-prem, what are you responsible for? Everything that's in green. Well, that's everything on the list that we have for us to use. Infrastructure as a service, what are you responsible for? For that virtual machine, that operating system. So do I have to patch it? Yep. Do I have to back it up? All those things. IaaS is what we're responsible for. If you look at PaaS, all you have to worry about is developing your application. Developers still develop, and they still have to have right access to it. Versus software as a service, guess what? They just have to worry about data and access. Now, generally speaking, at a real high level, when you move from infrastructure service to platform as a service, from IaaS to PaaS, you're going to save money in your cost consumption model. Why? You're consuming less resources. You're just leveraging the application. You don't have to worry about the operating system or the virtual machine. You don't have to worry about maintaining that from a cost perspective. We see a lot of customers now that are in that kind of crux. Do I just take my VM from on-prem and do what is called a lift and shift and move it into a VM in IaaS? If you do that today, I'm willing to bet tomorrow you're going to say, you know what? I don't want to run that VM anymore. I don't want to pay for that virtual machine anymore. I want to just re-architect or refactor or redesign my application into a platform as a service so I can get out of that business. I don't have to worry about that anymore. And you're going to save money with most Azure services by doing that. A lot of our customers today are looking at, hey, I want to migrate to Azure. Moving that VM, lift and shift, is generally not their first option. It's the option of last resort. In other words, you know what? I can't get the application to work the way I need to just yet. I'll move the VM up because I need to leverage cloud resources for it and whatever else I want to do. And they're going to leverage infrastructure, but we see them on a journey. And now it gets interesting when we start talking about platform as a service. This means your organization has the skill and the developers to be able to write and work with those applications. But guess what? We have software as a service inside of Azure as well via what is called the marketplace. So the question becomes is, do I build my solution or do I buy the solution? Something in SaaS to leverage inside the cloud services we have. So when we look at this, folks, it's really designed to solve the problem and how you want to solve it, what's going to be the best, and what is it going to cost you to do all of that. Now, a couple things I love about this slide. First off, from a Microsoft perspective, all those services can talk to each other, from on-prem to IaaS, PaaS, and SaaS. These services can all leverage each other. More to the point, Microsoft is the only cloud company today that does all four of these. Our DNA was built on Windows servers. We leverage IaaS, PaaS, and SaaS. So when we think about this, we're the only company that understands all four modules, or all four modes of this. The cool thing also about our company, everybody goes, well, you know, when we look at one of our biggest competitors, Amazon, they jumped out to a huge market lead. And in recent years, we've caught up, and it's going to be a seesaw battle for the next, probably as long as our lifetime is, that's going to be there. But where did Microsoft start? We started as platform as a service. Why? We're a software development company. Why do you think we developed the Azure PaaS services? For our developers in the company to get more efficient, more agile, get global reach, customer latency, get elasticity, all built into the services. It's in our DNA as a development company. Where we see the organizations going in the world today, and this is Gartner and Forrester and any research organization, people are leaning towards PaaS. And they're leaning at leveraging either Azure or Amazon to do that. But that's when you look at those general modules, it's in our DNA, folks. Our PaaS story is incredibly strong because, and not to belittle any of our competitors at all, but it's incredibly strong because it's in the DNA of our company. We were born to be developers. Everybody's like, what's Microsoft do? We're a software development company. And so we have a great platform, and we understand because we built things for on-prem before we built Azure. Even though we had cloud in 95 with the Windows update, we have the ability to work with this. And so when I look at comparison, just as a summary of all of this, IaaS, infrastructure service, it's a flexible cloud service because really it is, hey, I want to move that machine from on-prem into my cloud environment, and all you have to do is configure the hardware. From an IT pro standpoint, this is where a lot of people start with cloud. Hey, that application's familiar. I know that operating system, whether it's Linux or Windows. And, oh yeah, I did say Linux. We'll talk about that in Module 2. We also have platform as a service where we just focus on developers. Developers like to develop. Now, the cool thing about this, when we think about PaaS services, I'm starting to get these questions again, Garrett. They're starting to go, wait a second, PaaS is going to take my job. What's going to happen when those folks come into PaaS? Well, guess what? You still have to have governance. You still have to have security. You still have to architect networking. You still have to architect storage. You may not have to worry about those virtual machines anymore. And guess what? When IT pros learn that, they're like, wait, I don't have to worry about updating? No more Patch Tuesday in a PaaS service? No. Who does the patches in our servers if you're running on PaaS? We do. That's our responsibility to make sure those servers are safe and secure when you're running those workloads inside of it. And then, of course, we have SaaS, which is pay-as-you-go. So when you look at all those models, you got to keep them straight. And for the exam folks, you have to keep these straight. They're going to ask you on the exams, hey, what's the difference between this? Or give you some scenario, what would you use, IaaS, PaaS, or SaaS?
You know, that's a really great question, Matt. We actually have a lot of activity happening behind the scenes in the chat happening here, people that are attending. And there's a great question, and I'm curious to know this too. How do you personally keep IaaS, PaaS, and SaaS straight in your mind? I mean, these are all potentially new terms for us. So how would you look at those three and just separate them and keep them in your mind as how you look at them?
So I would love to take credit for what I'm about ready to show you, and it's been on the internet for a long time. But let me ask you a question, Garrett. Do you like make-at-home pizza? Is that a fun family night? You got 5 kids, and I mean, I know you want to do pizza. Everybody likes pizza. So do you have that fun family night of make your own pizza?
Yeah, no, we absolutely do.
Okay. So how I think about this, how I keep it straight, I like to think of it as pizza as a service. All right. Now, when we look at this, when we think about on-prem, that's your fun family night. That's making pizza at home and work with it. Now, people listening to this are going, wait a second, Matt, this breaks your cost model. This now, we do make it on pizza night. What's the major value add, the value prop when you do make it on pizza night?
Well, you get to pick and choose how you want your pizza to be.
Pick and choose, and it's quote unquote less expensive, right?
Yes.
All right. Now, what I'll tell, and especially with 5 kids, it's a concern for you. But Garrett, now next time your beautiful bride comes along and says, "I want to do make it on pizza night," I got a solution for you. All right. So when we think about this, yes, the ingredients will cost less. Your pizza, your dough, your tomato sauce, whatever toppings that you have will cost less. They're not going to be the same quality as restaurant quality, or even if you have take and bake pizzas or even delivery, they're not going to be the same quality. But also, what goes into make it on pizza night? You have to turn on an oven. You have to have an oven first off. Have to turn it on, and now there's like these new ovens that are out there that are just designed to make pizza. I have to go get them because they can make a pizza in a minute. I'm like, I'm in when it's there. But also, who cleans up? What's the rules at your house? So who cleans up whenever you have dinner?
Well, whoever cooks doesn't do the cleaning.
Yep.
So typically my wife will cook and I end up cleaning everything afterwards.
Yep. And do you like to clean?
Not my favorite thing to do.
Not your favorite thing to do. Or the kids have to get involved with that. Have you ever had, remember Caitlin, she loves bacon. Have you ever had they took the last piece of bacon argument in your house?
Yeah, that typically happens frequently with all of them.
Emotional cost, right?
Yes.
And then when you take away electronics, that cost keeps going over the next week, right? The point is, when you look at the total cost of ownership with Make It Own Pizza, that's why we talk about this. Will it save you money? No. If you look at the whole cost of it. Saves you money on the ingredients, yeah, I'll give you that. But you have to look at the whole cost of an inside environment. And with Caitlin, when you get the last piece of bacon and she hasn't gotten it, there's a lot of arguments that happen. Pizzas get spilled, dumped, and like I said, we're all scared of it. But when you look about this, how I keep it straight. Infrastructure service, IaaS, that's take and bake. You go to your local grocery store, and in Texas, we have a thing called Papa Murphy's where, hey, I want this pizza. I still got to take it home and cook it. I still have to maintain it. Or I have it delivered. I just pick up the phone, call somebody, and they deliver a pizza to my house. Or I go out to eat, and I can leverage all that. Now, dining out has some costs associated with it, but which is more expensive? So the next time your beautiful bride comes to you and say, hey, I want to go out to eat, or I want to make pizza night, and you say, no, Matt said it's cheaper for us to go out to eat for pizza, and you can put all 5 kids in your van, and away you go off to eat dinner. So that's how I keep it straight. It's a fun way to think about this. I don't think, although I don't know 100% certain because I don't have privy to the exam questions, you'll be quizzed on pizzas and service. But my friends, it's a way you can keep it straight in your head. It's a way you can keep these different terms. If you've never heard them before, you're going to be tested on them. So how do we work through them? So that's pizza as a service. With that brings us to the end of Module 1, where we talked about the different types of computing models. We talked about private versus public versus hybrid. We talked about some of those key terms, elasticity versus scalability, where remember elasticity is dynamic scalability we have in the cloud. We also talked about how to keep straight infrastructure as a service, software as a service, platform as a service, IaaS, PaaS, and SaaS, especially when we compare it to on-prem. In Module 2, we are going to cover some more technologies around all these services, and we're going to focus squarely on Azure, on how Azure is physically designed, as well as some of the services that will run on top of it. Let's get into Module 2, Azure Core Services. And when we look at this module, we're going to talk about not only the core physical components of how we build our data centers in our regions, we're then going to take a look at a lot of the products and solutions and even all the management tools we have available to work with Azure. As a good friend of mine on our team says, we're going to go an inch deep and a mile wide. And guess what on your exam, folks? you're going to have to go an inch deep and a mile wide. You'll have to know the concepts of these different technologies. You really won't have to know how to do a lot of this stuff, but you'll have to know what they are and what they look like. So when I look at the online learning course, anything that says core services is a great area to focus because you will be tested heavily in this particular module. So when we think about this, let's look at the core Azure architectural components and how do we design our data centers. It first starts off with big buckets we call geographies, and they really help us contain our different data center areas, which we call regions. And the good thing about this, we set up our geographies from a data residency, a compliance, and we try to make sure that all the applications and everything that run in those geographies are all closely related by their regions. Inside of Azure, we have Americas, Europe, Asia Pacific, Middle East, and Africa, where we store all of our regions inside of it. So we have this big geography, and this is something we design at Microsoft. You as our customers don't worry about this, but just understand that everything goes into geography. And inside the geographies, we have our regions. Our regions represent a collection of data centers, and we have regions all around the world. We have a lot in the US, we have a lot in Europe, we have them in Asia Pacific, but when we think about our regions, they're a collection of data centers. Important to note here, especially when we talk about some concepts coming up around availability zones and sets, understand a region is a collection of data centers. On the average, talking with some of the folks in the product group, an average region will have 16 data centers. Now, folks, I want to make sure I'm very clear with this. Sometimes a data center will look like, hey, this is all the same place. Well, when you see the picture of a Northern Europe region, which we actually think it's most of the Northern region, it's going to look like one building. But in reality, they are separate facilities, and we'll talk about that in a moment. But the main point is they have separate heating, power, cooling, networking. They're a separate facility. Although they may look like they're under the same roof, in reality, they're separate facilities. Why do we have regions? Gives us flexibility and scale, gives us data residency inside of our environments. They allow us to work with our deployments. They're really global services. And the good thing about regions, you can find resources that are all around the world for you to do your job. But be careful. Although this is not, not big differences, but not all regions are equal. Some of the regions have different resources, especially our newer regions. Will, from a virtual machine perspective, we'll have some of the newer hardware for those virtual machines, where some of the older regions may not have some of that new hardware.
Hey, Matt, so I understand that, hardware choices, that's one of the things that could pick this region versus that region. But as I'm thinking about architecting a solution, let's say I'm brand new to Azure and I'm watching this, what are some of the other reasons why I might select one region over the other?
Yeah, and so the first one is definitely making sure you pick a region that has all those necessary features and functions for whatever solution you're building. But the other things might be cost. If you think, for example, we talked about economies of scale. West 2 on a lot of the resources are less expensive. So I might pick a region where I'm not really concerned that it's too far apart. But we're also going to pick regions from a standpoint of what's closest to our users. The general rule of thumb with regions, you're going to pick the region that is closest to the people that are going to be using that data. And so when we look at the regions that are around the world, you're not going to be here, I don't know, in Seattle and pick a region in Africa to put your data. You're going to pick one of our West Coast regions for this. Or you're going to pick a region that might be driven by compliance. For example, we have Canadian regions that are available too, and most Canadian customers don't want to cross the Canadian-US border for some compliance issues. So they're going to use the data center that are up there and local to them. And so we're going to look at that. We're also going to look at latency. And when you look at solutions like the Olympics, they have to be able to distribute content around all the regions. The most important thing about this, you put the data in the regions that you need to choose. We don't choose them for you. You choose the regions. The geographies have some nice things for us, and we work with, and we'll talk about in a second, with region pairs, because every region has a buddy. And that buddy is designed for our fault tolerance, for our disaster recovery. Something happens to a region, we can fail over to another region for it. So really, cost is going to be a concern, and then location is going to be one of those other areas that we want to work with. And then also making sure we have the right services are some of the common reasons we choose regions. And sometimes, that feature, hey, I want to use that new feature in Azure, it's not in region 1, but I got to use region 2 to get a hold of it. So there's lots of factors. It's a very easy decision to make. It's just drop down list. But now you got to make sure you pick the right one. And that's not even mentioning we have special regions we'll talk about in Module 3 for the U.S. government and for China data centers. So we have some special issues with those of how we adhere to the compliances for the China government and U.S. government as well. And we'll talk about those in Module 3. I mentioned this, every region has a pair inside of here. This is a small subset of the region list. We have lots of regions around the world, but you see some of those common pairs. The general rule of thumb is every region pair has to be at least 300 miles apart from each other. So we're talking about huge physical separation between this. This is done by design. You don't pick the region pairs. Once again, just like our geographies, at Microsoft, we design these region pairs. It's really designed in case one of our regions goes down, we can fail over capacity to this other region pair. Bear in mind, we also look at inside those regions, we have capacity if something happens inside the region, we can fail over with inside the region before we go to the other region. We also do updates in a very controlled fashion. We do not update both pairs at the same time. We update pair, region A, get that update, and then we update region B. So we do it in a very controlled fashion, so we don't want to do this at the same time. The reason we have this is in case something happens inside the region. Now, I actually asked a product engineer, I said, what if both regions in the region pair go down? Technically possible, and the answer I thought was pretty interesting. At first it might sound flippant, but he says, Matt, if both regions go down, that means dinosaurs are roaming the earth. And understand what I just asked them. Two separate physical facilities separated by at least 300 miles that have over 600,000 computers in each of them go down at the same time. Is it possible? Yes. Is it likely? Most likely not. But if it does happen, that means there's bigger fish to fry, that something else is happening in the world that's causing that huge outage. And that would be a massive outage. Do we have regions go down? In my career, I've only seen a couple times where regions went down for periods of time. And just be very clear, this is not acceptable. This is why we have service level agreements. We'll talk about those in Module 4, and why we make sure we help guarantee those. If those things do happen, our customers get full credits. When I've seen regions go down, I've seen customers get a full monthly credit on their bill for those outages. And the worst outage I've seen as of recent was a 19-hour outage we had, which was a really bad outage. Now, here's a cool thing about this. Not to say that regions could be brought down for longer periods of time, but when you think about how we design the data centers, and it comes back to that dinosaurs roaming the earth, folks, not saying the region couldn't have gone down for a longer period, but my rose-colored glasses come on for a moment. A region was down for 19 hours, but the true story was, and the true kind of information that's important, the region was back up in 19 hours. And that region in question got hit by multiple lightning strikes is what brought that region down. And it was back up in 19 hours, fully functional. So when you think about our data centers, and you think about these global companies, especially Microsoft that does this, we've been in this business for a long time and we know how to design them to be very resilient. So let's take a look at a region. It's my favorite region. It's where I'm hoping Garrett will send me one of these days. I get to go to the Dublin, Ireland. This is, although there's a lot of debate on this one, this is most of, if not all of, the Northern Europe region capacity that we have. Look how big the facility is. And if you just look at the cars that are around it, you get a general idea of these facilities. On the average, most of these facilities are 400,000 square feet in size. They have multiple power centers. They have multiple heating and cooling. They even have a lot of physical security. It might be kind of hard to see, but if you're looking at the picture, you might see the roundabout has a big cement barrier. You can't drive straight into the facility. So there's a lot of physical security here. And by the way, if you're not on the list, you don't get in the facility. I mean, even if Satya were to walk up in the data center, if he's not officially on the list, the data center techs will not let him in. Now, I'm pretty sure Satya probably gets put on the list, but he'll have to be on that list. Not saying he can't get on the list, but he'll have to be on the list before they let him in because there's so many compliances our data centers adhere to. There's a lot of internal security. So if you ever get a chance, if you're a Microsoft rep ever, I invite you to go to a data center tour, go, because you'll learn about the physical side of Azure where all your stuff is. And our cloud services run in these regions. Now, if you look at this, you said, well, Matt, a region's made up of multiple data centers. It is. You actually see at the minimum at least 3 in this picture. You have on the very top of this environment, you have that big long strip of white at the top. You have the building in the middle, and then you kind of have the building that's kind of out back. If I had to guess, and I don't know for certain, but those are 3 different facilities. I even could take this a step further, and this is kind of a debated question with me and some of my teammates. If you look at the top facility, you see different towers. Now, I don't know what those are. My guess is, and because I can't zoom in enough, those might be separate electric and power and cooling. But the point I want to make is even though this looks like one facility, In reality, there are multiple data centers in this one geographic footprint. And that's how I think about it. So we're looking at a region, and we have these multiple data centers that have separate cooling, networking, and power. There's even separate physical firewalls that will separate it. And kind of a fun story, I got to tour the South Central data center, which is in Texas, and the person giving us the tour had us stop midway through the tour and had us look up. And we all look up, and there's a giant block of cement above our heads. And he's like, "What is that?" And we're like, "I don't know, what is it?" Well, that's the firewall. That if something happens on this side of the facility, we can drop that wall, it'll physically separate the two data centers. We design these for data resiliency in case something happens. As I was slowly stepping to the side to get underneath said block of cement, because on my brain I'm going, I hope they carried the one inside of there. So when we look at these facilities, you get an idea, and I want to make Azure real for you. And you can look at it. We have lots of videos online on our site where you can kind of see the physical design of this. For me, I'm curious about this. Is it something you'll ever go in and tour? If you get a chance, go. But folks, you have to understand where your stuff is going to be inside the facility. So we start with geographies. We have our regions. Our regions have multiple data centers, and every region has a pair. And that pair, by the way, only exists in the geography they're in. So we're not going to have a region in the US pair with a region in Europe. Those are separate geographies. They have to be inside that same geography of those region pairs to work with it. So Northern Europe pairs, I believe, to either Central Europe or Southern Europe. I can't remember the pair off the top of my head, but we designed them for resiliency, and there's tons of stuff that's inside of here. I could go on for days about the tours and my experience down in South Central. My favorite, though, out of all the stuff I'll tell you besides the firewall, in Texas during the summer, people turn on their air conditioning. There's a lot of power demands on our local power company in Texas. The local power company can actually call the data center and say, "We need power, we need to take you off the grid." And the South Central data center region can completely disconnect from the local power company and run self-sufficient on just the battery backups that are inside the facility. So my friends, these things are designed to withstand a lot, and they're great environments. And South Central is one of our older data center designs. We're getting even better at this as the generations expand. So with that, why do I spend time on this? We have two critical components that we're going to work with in availability zones and availability sets. Now, before I dig into zones and sets, let's talk about what they're trying to do. First off, zones and sets are for at least 2 virtual machines or more. So I am squarely talking about IaaS here. I'm squarely talking about infrastructure as service. Zones and sets are only for virtual machines. You got to have at least 2 or more. Zones and sets are also mutually exclusive. You either pick a zone or a set to do what they're going to do. All right, so you got to pick them. But what do they do? Well, inside of our data centers, we have updates. We have to update our data center facilities just like everybody else. We also are running on physical hardware, which means we might have faults from occasional time. A hard drive might fail, or a rack might go down, or a network switch might go down. This is a physical computing environment, so we might have these faults. So what we have to do is work with our virtual machines. And when you think about the possibility of something happening from an update or a fault, how do you make sure your virtual servers are still available? So if we have 3 web servers that run our front end, I don't want an update to bring down all 3. It might bring down 1, so I'll lose some capacity, but I'll still have my solution being available to me. So zones and sets are designed to essentially make your applications fault tolerant and update tolerant. They're designed to make sure that those systems keep up and running if something does happen on our side. So it's our way of saying, hey, look, an update, we don't want it to impact you. Zones and sets are also free. They don't cost you anything. Now, the resources running in a zone or a set definitely cost you something, but this is the design and architectural decision. When you choose a zone or a set, it also locks you into a region for those virtual machines that are going to be in that particular zone. So when you design this and say, hey, I'm going to make an availability zone inside of South Central, guess what? You're locked into the South Central region for all those virtual machines. This also has to be done at the creation of that virtual machine. If I just created a VM, but I forgot to put it in the zone, you'll have to recreate it. Now, there are some ways you can export that VM and re-import it, but you're essentially exporting it and recreating it inside the zone, but you have to do it at creation time.
Well, and Matt, I think it's important to notice that you showed us in the Dublin slide that there are independent facilities for power, for cooling, for networking. Yep. And I think that's really important for everybody to understand is that one of the key benefits of these availability zone is if we have a power outage in this availability availability zone and you have your second VM in the second availability zone, then you will not go down in that scenario because you have independent power and networking there.
Exactly right, and that's an availability zone. And so that gets into how do we make our VMs be fault tolerant and update tolerant. And what you described, Garrett, was electricity went out. You just described a fault. So we're not just talking about a hard drive failing here. Now we're talking power to that facility. How do we make sure we keep things up and running for your solution? But you as a customer of Azure have to make this choice. You have to make what I want, a zone or a set. Now zones are a relatively new construct. And generally our advice is if you see an availability zone, if it's available in the region, choose that. Sets are an older construct and they've been around forever, but how they do their job are differently. And so when we start with the zone, we're talking about, as Garrett mentioned, those two different regions. So if we look at if you think about that Dublin data center, we had those 3 facilities. If I have 3 web servers, what will happen is when we tell Azure to use an availability zone, under the covers, Azure will take a VM, put it in zone 1, take the other VM, put it in zone 2, and take the last VM and put it in zone 3. So that in case one of those data center facilities inside the region goes down, guess what? We still have the other 2 up and running. All right? Our solution's still available. Now, you have to start thinking about, well, wait a second, it's available. I lost a third of my capacity. I just lost one of my 3 web servers. And that's what will happen potentially if an update or a fault hits that zone. Well, what do you do then? Well, either just make sure those servers have enough capacity so they can run and 2 servers can run your full solution. But that's where a concept called scale sets come in, and we'll talk about that in a little bit, where we can say, hey, these are increasing, let's add some resources, and it'll take care of it for us automatically under the cover. So we have the ability to work with it. So the nice thing about zones, they provide that great isolation boundary. They give us independent power, cooling, and networking of how they become update and fault tolerant. Because guess what? We don't update all the zones at the same time. We update zone 1, then we update zone 2, then we update zone 3. And there's 3 availability zones in every region that you can choose from for your different solutions to run, but you have to make that choice. So now bear in mind, we started with geographies, we went to regions, multiple data centers in that region is where zones live. Its counterpart are availability sets. And availability sets, I want you to go, okay, geography, region, data center, racks of computers. Although inside of our data centers we use containers, we use physical containers, I should say. They're IT pack compute containers. But think about just multiple racks of computer. Now what happens when we get down into an availability set, we're inside of a single data center, inside of a region across multiple racks. Same concept. I put those 3 virtual machines in different what we call fault domains. You can have up to 5 fault domains inside of a availability set, and up to 20 update domains inside of a availability set as well. You have the ability to separate all these. And once again, what you're telling Azure and you're telling Microsoft, look, I don't want a patch or something hardware like an electrical outage or a workload to fail or a different rack to go down. I don't want that to impact the availability of my virtual machines. And remember, you need at least 2 virtual machines to use a zone or a set. And what that does, it just distributes them. So those single points of failure, guess what? It doesn't impact the availability of whatever solution you're deploying inside of our Azure. Key notes here, locks you into a region when you choose a zone or a set. They are mutually exclusive. You can't choose a zone and a set. You got to pick one. Our general recommendation, if you have a zone, use it. It's going to give you a little bit more of a better SLA, which we'll talk about in a second. But we also look at it, fault and update tolerance. That's what we're trying to design our solution. And what level do you want to live at? What's your application compliance going to work with? All kind of determine that. You'll see sets pretty much in all of our Azure regions. You'll see zones in a lot of our newer regions inside of it. When I look at this, why do we choose a set or a zone? It's all about part of it, it's about performance and resiliency. But when we look at our SLAs, our service level agreements, when you choose an availability set, you get 3.5 nines for those VMs, availability and uptime. And what does that mean? That means that that server is going to run 99.95% of the time. And in module 4, we'll make those numbers a little more real and kind of give you an idea what that means from a time perspective. If you choose a set, you get 3.5 nines. If you choose a zone, you get 4 nines. And so why do I recommend zones? You get a better SLA. You get that same resiliency. It works a little bit better for us. Now, when we think about what we're doing with a zone, you're basically saying, Microsoft, I don't want a data center to bring down my solution. If something happens, I don't want to bring down my solution. There's another way to do it, and that's when we talk about region pairs. You can deploy one VM in region A and one VM in its region pair, and guess what? You now have data center resiliency, and because they're pairs, you have update resiliency. So there's ways to design solutions to leverage the built-in architecture for Azure. With that said, most customers live in zones or sets when they're trying to design that resiliency inside of it. Now here's a cool thing. We were the first company to do this. What if I just have one hand clapping? What if I just have a single server? I'm not going to need a buddy. It doesn't need a pair. Don't want to do anything else with it. Can I get an SLA for it? You can get a service level agreement. You can get 3 nines for a single VM, but you have to make the VM with what is called premium storage, which is performance. And by the way, if IOPS and disk performance is important to your solution, you're always going to choose premium storage. But you also choose what is called managed storage. If you choose premium and managed storage, Azure will give you 3 nines for that single VM. So you can still get an availability, you can still get an SLA for a single VM. But most times when you have a virtual machine running inside of Azure, guess what? You're going to put them in a zone or a set depending on what's available inside of your region.